a fraction apart. So you know that if you're adding two fractions, you find the common denominator and you do the multiplication that you need to do and bringing it together as one fraction. Well, we're going to try to pull something apart because that'll make it easier to integrate. So let's say I have the integral of negative x minus 5 over x squared minus 2x minus 3 dx. So I'm going to try to break this up into separate fractions. I see the bottom can be factored as x minus 3 times x plus 1, which means negative x minus 5 over x minus 3 times x plus 1 can be written as two fractions where one has x minus 3 on the bottom and the other has x plus 1 on the bottom. Now these are linear factors, so if we go 1 degree less than that, we just have a constant. So I'm going to stick a big old A here and a big old B here. Now, going back to here, if I had just these two fractions and I was trying to bring them together, I would have A times x plus 1 plus b times x minus 3 all over x minus 3 times x plus 1. So now I've got two fractions with the same bottoms, which means they must be equal. The tops must be equal. So this means I have that means the top must be, well, I can't remember what I was saying anyway, a times x plus 1 plus b times x minus 3 has to equal the top over here, negative x minus 5. So now we need to solve for a and b. And the easiest way of doing this, I think, is to plug in numbers and plug in particular numbers. So if I let x equal 3, now this expression has to be true for all x. So I'm going to pick some convenient x's. If x equals 3, then this expression is 0, and this is 4. So I have 4a is equal to, if x equals 3, negative 3 minus 5 is negative 8, which means my a is equal to negative 2. So now I know what a is. Let's try, now another convenient choice would be x equals negative 1. If I stick negative 1, this term goes away. So I have b times negative 1 minus 3, which is negative, oh cool, negative 4 again. And if I stick a negative 1 in here, I will get a negative 4. So that means b is equal to 1. Now this means I can take the integral of negative x minus 5 over x squared minus 2x minus 3 dx, rewrite it as the integral, well, let's see, my a was negative 2, so negative 2 over x minus 3 plus 1 over x plus 1 dx. These are easy to integrate. The derivative of the bottom is just 1, so I multiply by negative 2, but these are natural logs. So negative 2 natural log of x minus 3 plus natural log of x plus 1 plus c. And if you want to get fancy, you could bring the logs together, but you don't have to. I'll have the natural log of x plus 1 over x minus 3 squared plus c. So that is a partial fraction. So if your factors are linear, you will put constants on top of them to break it apart. If they're not linear and you cannot factor them, then you have to put something that's linear on top of it. Okay, what do I mean by that? That's a lot of gobbledygook. Okay, let's say you have the fraction negative 3x squared plus 2x minus 11 over, oh, let's go ahead and x cubed minus 4x squared plus x minus 4. Okay, so let's factor this. I see that I can pull an x squared out of these two terms. So now I can factor out an x minus 4, and I'm left with x squared plus 1. So this can be rewritten as something over x minus 4 plus something over x squared plus 1. We want to make sure we get every possibility, and these are lower degrees than the top is a lower degree than the bottom. So for this one, I'm going to stick a constant on top, an a. This is a square, and I can't reduce it. X squared plus 1 is not factorable. So I'm going to need to put something linear on top. So I'm going to say bx plus c. Now we need to figure out what a, b, and c are. So bringing these together, I'll have a times x squared plus 1 plus bx plus c times x minus 4 all over x minus 4 times x squared plus 1. Which means if we compare the top, I'll just give myself some more space here, I'll have a times x squared plus 1 plus bx plus c times x minus 4 is equal to negative 3x squared plus 2x minus 11. So I want to figure out what a, b, and c are. So the first thing I'm going to do is kick the cat in the butt, is x equals 4 looks convenient. Let x equal 4. So if x equals 4, this expression is gone. 4 squared is 16 plus 1 is 17. I get 17a, 17a is equal to, I plug 4 into this, and I will get negative 51. No, I didn't do that in my head. I already figured it out. So a is equal to negative 3. Now the next ones are going to be more of a pain because I don't have roots here. I mean, I could conceivably use I and negative I, and then I'd still have a couple of equations to play with. So let's just try to get a couple more x's in here. Let's say if I have x equals 0. 0 is always nice. That gives me a plus, okay, your b is gone. That's a 0, so I have negative 4c equals to negative 11. Now I figured out that a was negative 3. So adding 3 to both sides, I get negative 8, which means c is equal to 2. Okay, so a is negative 3, c is 2. I need to figure out what b is. One last equation to figure out. Pick your favorite number, but don't go crazy because then it'll be obnoxious. I like, let's say 1. 1's nice. So if I plug 1 into here, I'll get 2a plus b plus c times negative 3 is equal to, if I stick a 1 in here, I have negative 3 plus negative 12. So a I know is negative 3. I'm going to plug that in. So that makes this a negative 6 plus negative 3 times b. C I know is 2, so this is another negative 6 equals negative 12. Well, that's negative 12, and these two are negative 12, which means that this is going to give me negative 3b is equal to 0, so b is equal to 0. So now my integral becomes, or if I was going to, I just didn't even do it as an integral. So this expression, if I were to integrate it, I can write it as, let's see, a was negative 3, so negative 3 over x minus 4. B is 0, and c is 2, so then I have plus 2 over x squared plus 1 dx. Integrating that, I have negative 3 times the natural log of x minus 4 plus 2 times tan inverse of x. So you will either have factors that are linear or that are quadratic irreducibles. When they're linear, on top you put a constant. If they're quadratics, you put something linear on top, bx plus c. Now, another thing that you could run into, oh, I'm already at 10 minutes though. So I'm going to stop here. And I'll do a separate video for that. So that's how you do partial fractions, and I'll get into some nuances in the next video.